Welcome back. Today we're going to be going over another related rates problem related to calculus and calculus 1. It says two cars start from the same point. One travels south at 60 miles per hour, the other west at 25 miles per hour. Okay, so I'm going to first just draw a picture to illustrate what's going on here. So let's say that this is the same point that the cars left from. One travels downward south at 60 miles per hour. And then the other one travels west at 25 miles per hour. How fast is the distance between them increasing 2 hours later? Or, in other words, once the car that's driving to the west has driven 50 miles and the car driving south has driven 120 miles, how fast is the distance between them? So, the hypotenuse distance increasing at that point in time, right? Because keep in mind, if we're going due west and then also due south, we're going to end up with a 90-degree angle in there. Okay, so the very first thing we need to do here is write down the distances after the 2 hours. So the distance west would be 50 miles west. And then for y, it would be 60 times 2, which is 120 south. Okay? The next thing we need to do is we need to state what are the speeds. So the change in x with respect to the time would be 25 miles per hour. So dx dt is going to be 25. And then dy over dt, which is our speed or our rate of change for y with respect to t, is going to be 60 for 60 miles per hour. Okay, next thing I'm going to do is I'm going to use the Pythagorean theorem to find out when we have 50 here, 50 miles traveled here, and 120 miles traveled here, what is this distance here? What is the actual distance between the two cars at that given point? So to do that, I'm going to be using Pythagoras' theorem to find that, we'll call this c, that c squared is equal to 50 squared plus 120 squared. That means c is equal to the square root of 16,900, which is equal to 130. So therefore, their distance is 130 miles. Okay, so then what I'm going to do is we're going to use the related rates formula. So we know that c times dc over dt, so the change in c with respect to the time, must be equal to x times rate of change plus y times that rate of change, and then we just need to solve. So we already have all these things. We already know that c is 130. We don't know dc dt, but that's what we're trying to figure out. We're trying to find how much c, the distance between the two cars, changes with respect to the time. So that's what we're trying to figure out. And then that's equal to x times dx over dt. So x, our distance, is 50, times the rate of change, which is 25, and then plus y, so that distance would be 120, times rate of change, which is 20, or sorry, not 25, it's 60 for this one. And then we're going to solve. Okay, so then we're going to end up with dc dt is equal to 50 times 25 plus 120 times 60, which is 8,450 over 130, and that is equal to 65. So therefore, the rate of change at which the two cars are the rate of change of the distance between the two cars after 2 hours of them driving in this way from the same point would be 65 miles per hour. So A is our answer here. As always, if you do have any questions, feel free to leave those down in the comment section, and we'll see you for the next one.